Hi, I'm Tate from Inventables, and I'm here to show you how to build the Shapeoko 2 Works Kit. Alright, the first thing we're going to do is build the smooth idlers and V-wheels. Here's the technique for doing it. We're just pushing the Delrin pieces right onto the bearings, and we're making sure that the precision shim washer is in between the bearings inside of the assembly. And we're just going to repeat that 20 times for the V-wheels. You can use a piece of wood and press down on it to make it easier on your thumbs. The idler has two sides. You want to make sure that you're trying to push the bearing into the open side. And again, we're just going to drop that precision shim washer right in the middle there, in between the two bearings, sandwiched in between. So now you've got your 6 idlers and your 20 V-wheels ready to go. Next, we're going to assemble the carriages. Here's an exploded view of the carriage, the way it goes together. And a little tip here, with the V-wheels and smooth idlers that you've made, you may want to align them to make sure that the spacers are centered. So here I'm going to start attaching the V-wheels to the carriage. And as you can see, I'm putting a little spacer, or a little washer, in between the V-wheel and the plate. And I'm just doing this 4 times for each carriage, sliding them through the holes. So here you can see that there are 2 different sizes of holes on the carriage. The bottom holes take eccentric nuts, which have a little shoulder. You want to make sure to push that into the hole and seat it well. You can watch that here. The top holes are just regular washers and hex nuts. Now I'm just tightening this down. You want to get it fairly tight. You don't need to crank on it too hard. Next we're going to attach the idlers to the carriage. And you just want to make sure they're oriented correctly, so you can see that the open side is now going to face towards the plate. And on the back side, just another washer and a hex nut. You can see here that I'm aligning the spacers again in an idler. You can do this at any point. So here we have 3 fully assembled carriage plates. We're going to put the pulleys onto the motors before we put the motors onto the carriage plates. And you can see here that I'm just putting on the set screws. So there are 2 set screws for each pulley, and you can see that I'm just tightening them down onto the shaft now. That makes sure that the pulley doesn't rotate on the shaft. So here I am attaching the motor to the plate. And you want to make sure that when you put the screws in, you slide the motor all the way up towards the top of the plate. There's a good shot of that motor all the way in the top position. And now I'm just going to tighten these screws, and I'm just going to do it in an X pattern. Now we're going to tap the maker slide. The important thing here is to just go slowly for the first few threads with light pressure and make sure that the tap is perfectly parallel with the hole that you're attempting to tap. A lot of people get intimidated with this step. Don't worry about it. Just go slow and go easy. So you can see here that I've taken 3 full turns to get in, and then I'm going to back it out and wipe away the debris so that the tap can go in and cut new threads. You want to continuously clear out the threads that you've cut. So you've gotten 5 pieces of maker slide with your Shapeoko 2 Works kit. The shortest one is the Z-axis maker slide. You only need to tap 2 of the 4 holes on this piece, and make sure those are 2 holes on the same side. The other 4 pieces, you want to tap all of the holes. So here we have all 4 of the long pieces tapped on both sides. Now we're going to assemble the spindle mounting plate. This is just like the carriages, only we're using some spacers to stand the V-wheels off of the plate. This plate is just like the carriages in that there are eccentric nuts on one side and regular nuts on the other side. So make sure that you put the correct nuts in the correct orientation. The eccentric nuts go with the larger hole on the plate. So here I am just hand tightening the regular nuts on. And now I'll place the eccentric nuts in, and again I want to be sure to seat the shoulder into the larger of the 2 holes. Here's a better shot of seating the shoulder. Here I am just tightening up the V-wheels that we put on this plate. Again, you want to have them snug, but you don't need to wrench on them too hard. Now we're going to attach the Delrin nut. Make sure you get it on the correct side of the plate. And again, I'm just hand threading first to make sure that I don't cross thread these screws. Now we're going to attach the spindle mount. And here I'll just flip it over and attach the nuts on the back side with washers between them and the plate. Now I'm just going to attach the spindle mounting straps, and I'm just going to put the first few threads of these screws in. We'll fine-tune them later, we're just going to get them in place for now. Now we're going to assemble the Z-axis. Take your time with this step as it can be quite frustrating if you don't. So now I'm going to take the M3 screws, put the M3 spacers on them. And I'll put the first plate on these 3 screws. Now I'm going to put the nylon spacers, 2 per screw. You want to put the wider side of this bearing down. And this washer can go in any orientation. This can be a tricky part, so just go slowly and thread these standoffs into 1 screw at a time, using a little bit of pressure to expose the head of the screw. So here I'm squeezing a little lightly to make sure that screw comes through. Just hand tighten these for now. Make sure that you get the set screws in the correct holes on this motor. I've pointed out the ones that you want to use. So you want to keep the wires for this motor to the back, and you'll see what I mean once we get the Z-axis assembled. This flexible coupler has 2 sides. You want to put the smaller side onto the shaft of the motor. And don't tighten it too much now, just get it snug on there. So now we're going to turn those standoffs onto the set screws that you put into the motor. Just handle this lightly and go slowly. No reason to rush this step. And here I am alternately turning the standoffs and the screws. You'll notice as you tighten a standoff to the motor, you'll need to tighten the screw to get it back into the standoff. I've got a little hex nut here that's going on the threaded rod before it hits the coupler. And just make sure you get enough of the threads into the coupler so that it can grip, and then tighten it down. And now tighten the one on the motor too. You want these two nuts to be tight against the bearing. And now we're going to put in the last two spacers and just line them up with your hex wrench to make it easier. Keep the whole assembly on the table for this part. It's much easier to line up the holes with the maker slide. These are the holes that you tapped previously. It'll make it a lot easier to assemble the two sub-assemblies we're building now if you use a power drill to push the Delrin nut up the threaded rod once or twice. So when you're putting these two sub-assemblies together, make sure you have the eccentric nuts set at the widest possible spacing so that it's easier to get these two sub-assemblies together. It can be quite difficult to thread the threaded rod into the Delrin nut just by turning the coupler, so you can use the knob with the crank that's been supplied with the kit. This knob has a set screw just like the pulley did, and we're just going to tighten that down. And then we can use the knob to turn the threaded rod through the Delrin nut. Here we're going to use insertion nuts, and we're going to make sure to use the flat part up when we put them in the slots of the extrusions. Line them up roughly, and then we're going to attach this carriage plate. No need to get it super tight right now. You'll want to line up the bottom of the maker slide with the bottom of the carriage. Now we're going to attach this assembly to another carriage that's got a motor on it. This can be tricky, so take your time. Align one to begin with, and that will kind of hold the carriages together. And then just go slowly. Make sure that you use one of each type of spacer for this part. There's one that's 1 inch long and one that's 1 1/4 inches. And I'm just hand tightening here. You may find that you need to loosen some of these screws in order to get the other spacers in. Be sure to put washers between the screw in the plate and the nut in the plate on both sides. You want to make sure that the grooves for the maker slide are facing outwards. And we're just using the holes that you tapped on the maker slide previously. You can see there are slots in the carriage plate. Again, here we're having the eccentric nuts give you the most room. See how the screw is down all the way here. And we're going to gently slide this on. No reason to force it. If it's not sliding on easily, make sure that your eccentric nuts are orientated correctly. This is a belt clip. We're just going to put it on temporarily in the right spot, using another insertion nut. Make sure it's on the side with the motor and the pulley. You want to push this back and forth along the maker slide. Just make sure that it's running smoothly. These end plates have slots just like the motor carriages. We're going to use the middle slot. And pull it all the way to the top of the slot before you tighten it. We'll make two of those, and they're mirror images of each other. You can see that the rails are pointed out, one for the left side, one for the right side. Putting some more insertion nuts in for belt clips. Here we're going to countersink the wasteboard. You want to make sure that your drill bit is vertical and go just deep enough so that your hole is the same size as the threaded insert. You could check this by flipping it upside down and putting it in the hole. And just go slowly with this again and make sure that your drill is vertical for each hole that you're countersinking. Then we're going to drive the threaded inserts into the wasteboard. Go slowly and just go to flush or subflush with the head of it. We're going to use insertion nuts again to attach the wasteboard to these extrusions. And just slide them down the rail with your hex wrench. Try to line them up with the 3 holes that are on the wasteboard. We're going to take an M5 screw and an M5 washer, a little bit of thread lock. Go for the middle hole first, because you'll be able to adjust the outer insertion nuts easier. And tighten it, but not all the way down, so that you can still have some room to wiggle with. Now we're just going to do the same thing with the outer 2 holes. And you can use the hex wrench to align those insertion nuts through the hole in the wasteboard if you can't see them too well. Then we're just going to do the same exact thing on the back side of the wasteboard. You can see here I'm using the hex wrench to align the insertion nuts through the hole in the wasteboard. This can help a lot. We're going to put 4 insertion nuts on the front side of this extrusion. We're going to use these to attach the end plates in a second. So here I'm sliding the y-axis rails through the gantry. And again, if this is difficult, make sure that your eccentric nuts are oriented in the correct direction. You want the screw to be on the bottom side so you have the most room. Now I'm going to put the end plates on the front side of the y-axis. Make sure to use thread lock here, and you want to pull the rail all the way to the top of this slot before you tighten it. That way it'll be level with the ones in the back. And get these screws nice and tight. Now we're going to take everything we just built and drop it over the top of the wasteboard. Should be kind of a snug fit, but just go slowly. And now I'm going to use the hex wrench again here to make sure that my insertion nuts are lined up with the correct holes in the end plates. Again, I'm using an M5 screw, a washer, and a little bit of thread lock here. Hand tighten them first to make sure you don't cross thread. And you can also push the insertion nut from the side with your wrench to line it up on the hole. I'm going to repeat this for each of the 4 end plates. And don't worry yet where the end plates are on the black extrusion. We'll line it up in a second. So now we're going to square up everything that we just built. I'm using a speed square here, but any flat 90-degree surface will do. And here I'm just going to snug the end plate up to the end of the extrusion on the left side of your machine. I'm holding in place and I'm going to tighten it down. I'm doing the same thing on the back left side now. And we're going to move generally from left to right to square this machine up. Now I'm going to check if the gantry is square. This is the x-axis. And you can loosen those screws that you used before to assemble the x-axis to make sure that it's square. The back piece of maker slide is going to be pushed all the way to the back of the slots. Now I'm just checking from the back side again here to make sure that this x-axis is square. Take your time with this part. You'll want to loosen the screws that you use to attach the z-axis maker slide in order to square the z-axis. Raise the spindle carriage all the way up so that you can get your speed square next to the maker slide. And then once it looks square, go ahead and tighten those 4 screws again. And now finally I'm going to square up the right y-axis maker slide. Again, making sure that the rail is all the way in the top of the slot on the end plates. The belt that you got is going to get cut into 3 equal lengths. Here I am using the wrong tool for the job. We're going to thread these belts through the belt clips. Here's how you do it. You want to put it through the farthest slot first from the screw, and then through the nearest slot to the screw, with the smooth side of the belt facing up, or towards the head of the screw. And then we want to make sure that the teeth of the belt engage each other when it's folded back underneath. Well, then I'm going to tighten this back down into the insertion nut in the maker slide. Here we're going to thread it underneath the smooth idler. You can use your hex wrench to kind of grab the belt. Then we're going to go over the top of the pulley. Pull up the slack, it makes it a little easier to keep it on the pulley here. And then we're going to go through the other smooth idler. So again, it's going under one smooth idler, over the pulley, and back under the next one. This can get a little frustrating, just take your time. And now we're going to do the exact same thing with the back belt clip, making sure that there's no twists in the belt and it's perfectly flat. And you want to pull some slack through here until you can't stretch the belt enough to reach the back end plate. Clip off a little bit of the excess, leave about an inch of belt underneath to engage the other teeth. And then we're just going to try and stretch that belt as much as possible and tighten the belt clip down. And then just roll that axis and make sure that everything's moving smoothly. We're going to do the same thing for the X and the other Y. Make sure you put as much tension as you can on the belt while screwing it into the maker slide. It should be really taut once you're done. Now we're going to start wiring. So here I'm just twisting all 4 wires of the leftmost stepper motor together and putting a little bit of heat shrink tubing on there. Just enough to reach from the motor to the maker slide. Then I'm going to feed those wires through the 2 X-axis maker slides and out the other side. Here I'm going to attach some terminal blocks to the back side of the gantry. I'm just using zip ties to do this because they're easy. I'm clipping the ends of the zip ties just to get them out of the way. Now we're going to measure some expandable sleeving and some heat shrink tubing for the Z-axis wires. Do the heat shrink first, then the expandable sleeving. This can be incredibly difficult and frustrating, so just take your time and try not to fray it too much. And then we're going to feed that end underneath the heat shrink tubing to clean it up. And the same thing for the bottom side here. I'm going to strip these wires so that we can put them in the terminal block. We've included a razor blade, but you can also use wire strippers to do this. And you want just about 1/4 inch of bare wire showing. So here's that heat shrink tubing going over the frayed part of the expandable sleeving to keep it neat. And I'm just going to loosen screws on the terminal block and insert the wires. You can follow the color orientation that I've used here, or you can use another one. It doesn't matter for the terminal blocks. I'm using some heat shrink tubing here just to clean up those wires from the X-axis motor. Then just use a heat gun to shrink the tubing. We're going to put another terminal block on the top of the gantry. Again, just use some zip ties here. And now we're going to put the spindle in. You want to get it hand tight first, and then crank it down evenly. We're going to bend these aluminum straps, so you want to do that in an even manner. And then just put the wires for the spindle into the terminal block. We're going to strip the zip wire that came with your kit. Pull it apart a little bit to make it easier to handle. And then just match up red and black. We're going to cut the stepper wire into the lengths shown. And you want to strip the shielding first without cutting into the wires. This is going to be hard to do, so just be gentle with it. You want to strip away this foil and string on the inside. And just cut those clean. You'll be left with 4 wires, just like the stepper motors. And you want to match up colors, black to black, red to red, white to blue, and green to green. We're going to do the same thing with the other terminal block. Now we're going to make something to mount the drag chain, which is that plastic stuff that's going to carry all the wires. We're just using insertion nuts like we had before. Make sure you get these brackets oriented correctly. There's one hole that's closer to the bend and one that's farther from the bend. So we're putting the hole that's closer to the bend on the extrusion here. And just flush up those brackets with the end of the extrusion. Here we're going to separate the drag chain. Count 3 links from the middle of the chain and break it there with a flathead screwdriver. You just want to insert it gently and just kind of wiggle it loose. Now we're going to put ends onto the pieces that we snap so that all 4 ends have end pieces. We're going to use the shorter piece for the x-axis and just thread the M5 screw through one of the holes. We're going to use another corner bracket to mount the drag chain to the x-axis plate. And just make sure you orient it correctly again. Now we're going to attach the drag chain to this corner bracket with another M5 screw, a washer, and a nut, and just come up from the bottom with the screw. And then feed all those wires that have to go through it. It's a good idea to tape them together at the end with some masking tape if you have some around. It helps them feed through the chain better. This is what it should look like once it's all fed through. We've got the spindle wires, the Z-axis motor wire, and the X-axis motor wire through that drag chain. Then just use a zip tie to keep those wires together. This will give it a little stability over the course of time. Now we're going to put this extrusion that we made back behind the X-axis motor. It can be a little tight fit, so just kind of wiggle it in there and line it up with the 2 holes that are right next to the V-wheels. And then use an M5 screw, a washer, and a nut right there. And this will be the mount where the drag chain attaches to the machine on the other end. So here we're just going to loop it underneath and screw the drag chain into that insertion nut that we put in the extrusion before. You want to test the movement of the x-axis and make sure that when it's all the way to the left of the machine, it's not binding. Here's another terminal block. We're going to use this one to connect the leftmost y-axis motor with the right y-axis motor. And I'm just going to trim some wires from the right y-axis motor so that we don't have a bunch of extra wire in the way. Strip those just like the other motors, and then we're going to twist them together with the left y-axis motors. We're going to do black to black, green to green, and then we're going to switch red to blue and blue to red. We're doing this so that the motors spin in opposite directions. And then we're just going to put these wire pairs into the terminal block just like before. Then I'm just going to shrink this heat shrink tubing that I used to keep those wires clean. We're going to attach the other stepper cable to this last terminal block. And we're going to do black to black, green to green, white to one of the pairs of blue and red to the other pair of blue and red. Now here I'm going to put another corner bracket on this plate, and that's to mount the drag chain for this side of the machine. Again, use some Loctite, a washer, and a hex nut. Make sure that the hole that's farthest from the angle is attached to the drag chain, and the hole that's closest to the angle is attached to the carriage plate. And we're going to thread all of the wires through this next piece of drag chain. You can use a piece of 3/4 inch heat shrink tubing here to clean up all the wires as they link between the two chains. Feeding it through the drag chain can get frustrating. It's a lot easier if you tape all the wires together at the ends first. Then shrink that tubing to make sure all the wires stay together. Now we're going to use another insertion nut, an M5 screw, to attach the drag chain to the back side of the machine. Slide that insertion nut in the back extrusion and screw it down. Again, we're going to test the movement of the machine after installing the drag chain to make sure it doesn't restrict. I'm going to clip all the stepper motor wires to the same length and strip them all. Leave yourself about 6 inches past the drag chain for some slack. Now we're going to put a black and a green wire together from one of the stepper cable wires and try and move all the motors. What we're doing here is shorting out a pair of wires, and when we try and move a motor that's shorted out, it will give us a lot of resistance. What we're looking for is one axis to resist motion. You can see here that the x-axis has done that for us. And you can check by untwisting the wires to see if the axis moves smoothly after that. Once you've found which axis that stepper cable belongs to, we're going to attach it to the G-shield. The little green things on the G-shield are also terminal blocks, and we're going to put the wires in there from left to right, black, green, white, red. And just do this for all 3 axes, making sure that you get all of the copper that you've stripped from the wire into the terminal block so that it's not touching the board. If it's hard to get the wire into the terminal block, make sure that you've unscrewed that particular terminal all the way. Now we're going to put the Arduino into the G-shield enclosure. Use the M3 screws and the washers that came with it to thread through all the 4 mounting holes on the Arduino. Slide the USB port through the enclosure. Line up all the screws with the nuts that are in the enclosure and then screw it down. Again, I'm doing this in an X pattern to make sure that I can get all of the screws threaded. Then we're going to take the G-shield and attach it to the Arduino. And there are pins that mate. Push gently, but firmly in the center. Next, we're going to wire the fan. First, you'll want to attach it to the outside of the G-Shield enclosure with the M3 screws provided. We're going to take what's called a pigtail adapter, which is that little piece of wire. We're going to take the pigtail adapter and split the end of it. You'll notice that one of the wires on the pigtail adapter is black, and the other is black with a white stripe. The black one is ground, and the black one with the white stripe you'll attach to the section on the G-Shield called V-mote. We're going to twist the red or positive side of the fan with the black and white wire and the black to the black. Screw these into the terminal blocks just like you did with the stepper motor wires. Place the top of the G-Shield enclosure with the fan on the enclosure and screw it in with the small M3 screws. Now we're going to attach the G-Shield enclosure to the Shapeoko. Use the M5 screws with a spacer in between the end plate and the G-Shield enclosure. We're just going to do the top 2 screws. Use a washer and a hex nut on the back side. Now you're going to clip the spindle wire, split it again, and strip the red and the black. And we're going to hook this spindle wire into the speed controller. You'll want to attach it to the left terminal block with the red on the left and the black on the right. You'll see it's also printed on the board, M plus and M minus, where it says load all the way to the left. We're going to use that extra piece of spindle wire that you have now. Strip it and put it into the next terminal block on the spindle speed controller. It'll be in the same orientation as the first one. The back side of this zip wire is going to go into the power supply. You'll see it's marked clearly where positive and negative goes, and any of those 3 will do. I use the 2 that are closest to each other so that I don't have to split the wire too much. And then we're going to attach the power cord there. Green goes to ground, black goes to neutral, and white goes to load. And then I'm just going to plug the pigtail adapter into the other power supply that we have. Unravel the wire for the pigtail adapter and split the black and the white wires from each other, making sure not to cut into the wire, just to split them from each other. Here I'm using a razor blade to do that. Be careful here, you don't want to cut into the copper. And I'm just separating the wires. Take the one that's black with the white stripe and clip it and strip both ends. And then we're going to wire them into this E-stop button, which will cut power to the motors. Make sure that you hook it into the orange side and not the green side of this switch. You're going to want to position this E-stop button close to where you'll be operating the machine so that you can reach it at any point in time. Now you have a fully assembled Shapeoko 2.